So now that we've seen a couple of different functions, let's talk about how to actually use them. When we had a computer program, we saw that we would take our function, type the name out, and then in the parentheses, where we know that the input goes, we could type a specific number, like 4, for example, like we did before. And then because the function was already defined in the program, when we ran this with an actual number as the input, it would give us an answer. It would spit out, in this case, a 1. We can do a similar thing for the mathematical version of this function. Once again, in the slot where the input goes, inside the parentheses right here, we can write a number. Let's pick a different one this time, just to spice things up a little bit. Maybe 5. Now the way that we use this new input of 5 is we substitute it into all the places where we see x in the expression on the right-hand side over here. So in fact, the first term we see is an x, so we replace that with a 5. And then the rest of the expression is the same. We started off with f of x equals x minus 3, and that means we know that f of 5 is equal to 5 minus 3. We can evaluate this to see that f of 5 is equal to 2. So 5 here is our input, and when plugged into this function, the function relates the input of 5 to an output, which in this case is 2. This, in fact, creates a point for us. We can now plot the point 5, 2. This is a point that lies on this line. Since we know that we're just replacing our dependent variable with f of x instead of y, we graph all the values of f of x of the function of the output, just as we would y values on the vertical axis. So what if we have a different function instead? Maybe f of x equals x squared. What if I want to plug in 4 as the input for this equation? What would the function give me as the output then? Please simplify your answer as much as possible so that it's just a single number.